Welcome back to Arxflix. Today, we're diving into the fascinating paper titled Reducing Transformer Depth on Demand with Structured Dropout. This research introduces a new technique called LayerDrop, a form of structured dropout, which aims to make transformer models more efficient and robust. Let's delve into the main findings and implications of this paper. Here's a helpful illustration of the LayerDrop mechanism. As shown in the figure, LayerDrop randomly drops layers during training. At inference time, this allows us to select subnetworks of any depth dynamically. This innovative approach not only regularizes the network, but also makes it highly adaptable. Transformers are powerful and have set state-of-the-art results in numerous NLP tasks. However, they come with a significant drawback. They have hundreds of millions of parameters, requiring immense computational resources and having a high risk of overfitting. This raises the need for a method to efficiently prune these models while retaining their robustness. LayerDrop is a novel structured dropout technique where entire layers are dropped during training. This builds a robust network where any subnetwork can be extracted without additional fine-tuning. The advantage is clear. We can customize the depth of our model at inference time without sacrificing performance considerably. Applying LayerDrop to transformer networks has several key benefits. Firstly, it regularizes very deep transformers, stabilizing their training. Secondly, it allows for extracting small, efficient models of any required depth at test time. Thirdly, it is as simple to implement as standard dropout. To validate LayerDrop, the researchers tested it across various high-demand benchmarks like WMT14 English Germ for machine translation, Wikitext 103 for language modeling, and SIN and DailyMail for summarization. Experimental results showed that applying LayerDrop to a 16-layer transformer improved performance by reducing test perplexity on Wikitext 103 and enhancing BLEU scores for machine translation. Notably, training with LayerDrop also enabled the training of deeper models that remained stable and achieved high performance. This figure illustrates the performance impacts of pruning on various tasks compared to traditional training approaches. The data shows that pruned models using LayerDrop outperform smaller models trained from scratch and baseline models pruned without LayerDrop. One of the intriguing aspects of this research is its comparison of various pruning strategies. Every other drops every other layer. Search on valid uses validation set performance to choose layers. Data-driven pruning learns the drop rate for layers based on data. Different forms of structured dropout were explored, such as dropping attention heads, FFN matrices, and entire layers. Among these, dropping entire layers with LayerDrop proved to be the most effective, particularly in terms of reducing the inference time and maintaining performance. The optimal drop rate for targeting a specific pruning size is given by. This formula relates the drop rate, P, to the desired number of groups, R, in a network of N groups. This figure shows the impact of structured dropouts, demonstrating that dropping entire layers yields superior performance compared to other methods. The key takeaway from this paper is that using LayerDrop can significantly improve the efficiency and robustness of transformer models. It allows a single large model to be deployed as multiple smaller, shallower subnetworks tailored to specific tasks or computational constraints, all while maintaining high performance. Structured dropout, especially LayerDrop, is a promising method for improving the efficiency and robustness of transformer networks. By allowing on-demand reduction in model depth, it offers a flexible and powerful approach to addressing the computational and overfitting challenges in modern NLP models. That's it for today's deep dive into LayerDrop. If you found this summary informative, don't forget to like, subscribe, and hit the notification bell for more insightful content. See you next time on Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.